All right, so we're going to go ahead and do the combustion lab. We're going to be doing procedure number 1, and I'm going to walk you through from start to finish. So it's important that you pay attention and you draw anything that I draw into the correct spaces provided for you. So step 1, it says to use the model kit to construct one methane molecule. That's what I'm working on right now. You can see that I've already assigned a key, and you guys should be using the same exact key. So carbon is black, oxygen is red, and hydrogen is white. So here's our methane molecule. You can see that it's got 1, 2, 3, 4 hydrogens and 1 carbon in the center. The directions also tell me to create 2 oxygen molecules. And that's molecular oxygen, which means it should have a formula of O2. I'm going to go ahead and create those. Now, this is 2 oxygens, but you can see that I have a bond that's open. So I'm going to add another bond to make sure all of these poles have a bond. It's 1 oxygen molecule. And here is the second oxygen molecule. Okay. And then it asks us to go ahead and draw these. So I'm just going to go ahead and draw them so that I have them. These to the side over here. Well, I'll just set it here right now. And then I'm going to go ahead and draw my CH4. It's not going to be perfect because I can't draw in 3D. Okay, so we've gone ahead and drawn these. Now it asks us, and mind you, this drawing should be on your questions section. So now we're going to go ahead and we're going to break the bonds in CH4 and O2, then rearrange the atoms to form new bonds and produce as many water and carbon dioxide molecules as possible. So these are the materials that I get to use. These are my reactants. And now using only these atoms, I have to create these 2 products. So I'm going to start by using carbon dioxide, which only has 1 carbon and 2 oxygens. So I'll need to remove all of these hydrogens. I'm just going to set them to the side so that I know I have to use them. Everything should be used up. Okay, so here are my 2 water molecules, or my one of my oxygens. I need to make sure that I cover up all of those bonds. There's actually a double bond between carbon because it's the central atom. A little bit of review there. So this is what carbon dioxide looks like. And it doesn't look like I have any more carbon to make any more carbon dioxide. So that's it. Now we're going to go ahead and make water, which has 2 hydrogens and an oxygen. So I'm going to add the 2 hydrogens to this oxygen. I'm going to go ahead and add 2 hydrogens to this oxygen. Remember that we only used what we started with. Okay, and there are my 2 water molecules. Now, how did I know how many to put there? Well, I just ended up running out of atoms. So now I'm going to go ahead and fill out this table. And to fill out this table, I really need to decide what the coefficients in front of each one of these molecules is going to be. So it's really just a matter of counting the number of molecules that were created. You can see here that CH4, there's only 1 molecule, so we would write 1. Here we have 2 molecules. Here we only have 1 molecule, and here we have 2 molecules. But in chemistry we're lazy, so we don't like to write 1, so I'm going to go ahead and just erase those. Now it asks us down here the moles of fuel that we have. The moles of fuel, or the moles of any of these substances, is directly related, or it's actually the same exact number as the mole ratio that we have up here. So yes, this tells us that we have 2 molecules of oxygen, but we can also say that we have 2 moles of oxygen. Okay? So right here, we only have 1 mole of fuel, 2 moles of oxygen, 1 mole of carbon dioxide, and 2 moles of water. Now I need to go ahead and calculate the number of or the amount of energy released per mole. If you look at the table, it gives you a unit. So don't forget to draw these, of course. I'm gonna move these out of the way. Make sure we draw our okay, so now we need to calculate this last box over here, and we're going to do that by, if you look at the table, it tells you that it's energy released per mole, and the units for that are kilojoules per mole. Look, you're already given a formula right here. So we can use this to calculate this last number. We have kilojoules right here, and we need kilojoules per mole of fuel. We only have 1 mole of fuel over here, so we're going to go ahead and use this value. That is 802 kilojoules divided by 1 mole of fuel, which will give us our final answer. 802 divided by 1 equals 802 kilojoules. And that's how you walk through number 1.